Imagine for a moment this vast, intricate web of power lines, substations, plants.
Mm.
It all just hums along quietly in the background, right?
Yeah, totally invisible most of the time.
But it powers literally everything in our modern lives.
Yeah.
It's this huge hidden infrastructure. And right now, it's going through a pretty radical transformation.
A really fundamental shift.
It makes you think, how do we actually get reliable, sustainable energy to everyone, everywhere,
Mm.
especially, in a world facing more and more challenges?
That's the core question, really.
And that's exactly what we're diving into today. We're going to unpack this fascinating world of decentralized energy systems.
Mm.
We'll look at what these systems actually are, why they're becoming so crucial, not just important, but really crucial.
Absolutely vital.
The benefits they offer, which are pretty incredible, but also the hurdles they face, because it's not easy.
No, definitely not straightforward.
And then the exciting innovations that are paving the way forward.
Right. So our mission here in this deep dive is basically to sift through all the different perspectives, the latest research.
Cut through the noise a bit.
Exactly. And give you a really comprehensive, but hopefully completely digestible understanding of this huge shift in how we get our power.
Digestible is key.
And this isn't just about fancy new tech, It's fundamentally about building a future that's more resilient, more equitable, and more sustainable for you.
Okay, let's dig in. A good starting point is probably what we all kind of know, the traditional centralized power grid.
The classic model.
Yeah, you picture those massive power plants,
Mm.
often miles away from where anyone lives,
Mm.
sending electricity through those enormous transmission lines, crossing huge distances.
It's an impressive feat of engineering historically.
Oh, absolutely. It's been incredibly successful. It really provided the backbone for, well, everything modern for over a century. But like anything that old, it has its weaknesses.
Its vulnerabilities, yeah. And what's really striking isn't just that these challenges exist, but how they're all kind of piling up at the same time.
Converging, you could say.
Converging, exactly. Let's start with just the age of the grid. I mean, a lot of this infrastructure is just old, decades old.
Like literally built in the 50s or 60s sometime.
Easily. Operating way beyond its intended lifespan. Honestly, some of this gear is older than the internet itself.
Wow.
You wouldn't rely on dial-up for your critical business today, right? So why are we doing that with our power grid?
That's a really good point.
And then add to that age issue. Rapidly rising demand.
Right. Electrification of everything.
Everything. Cars, heating. Think about electric vehicles. Just one EV charging at home can pull as much power as another entire house.
Seriously.
Yep. So that pushes the grid to its absolute limits, especially during things like those California heat waves we've seen.
And extreme weather generally, I guess.
Oh, absolutely. Centralized grids are incredibly vulnerable to big outages from natural disasters, hurricanes, wildfires. We saw it with that awful Texas winter storm in 2021.
That was devastating.
Costs something like $195 billion. And California has had those public safety power shutoffs because of wildfire risk. It shows the fragility.
Okay, so physical strain's a big one. What else?
Well, beyond the physical, there are cybersecurity threats. As the grid gets more digital, it becomes a bigger target.
Makes sense. More connections, more risks.
Precisely. We've seen high-profile attacks, like the one on the Ukrainian power grid back in 2015. It shows how attackers can cause widespread chaos.
Scary stuff.
And then there's a more fundamental design issue. The traditional grid was built like a one-way street. Power flows from the plant to you.
Okay.
But now, with things like rooftop solar, you have power flowing back onto the grid.
The two-way street problem.
Exactly. And the grid wasn't designed for that. It causes voltage spikes, trips, protection systems, stuff they just didn't plan for.
And I've heard about grid congestion too, like traffic jams for electricity.
That's a great analogy. You often have renewable sources, like big wind farms in really remote areas, far from cities where the power is needed.
Right.
If you don't have enough transmission lines, enough highway lanes, you get bottlenecks. The UK has actually paid wind farms to stop generating power because the lines couldn't handle it.
Wow, paying not to produce clean energy.
Crazy, right? And in the US, getting a new project connected to the grid, the queue can take over 5 years, just waiting for approval.
5 years.
Yeah. And finally, there's this software and situational awareness gap. Utilities often use these old, siloed software systems. Different vendors' systems don't talk to each other easily.
Making real-time coordination hard.
Very hard. And it increases the cyber risk, too. It's like this pressure cooker building up, demanding a whole new way of thinking about energy. We can't just keep patching holes.
That really does paint a clear picture of a system under, well, immense strain. So if that's the current state, what's the alternative? We hear this term decentralized energy thrown around a lot. What does it actually mean?
That's a really good question because, yeah, decentralized gets used a lot,
Yeah.
sometimes vaguely, but simply put, decentralized energy means generating and consuming power much closer to where it's actually used, moving away from those huge, distant power plants.
Okay, local power.
Exactly. And the building blocks for this are what we call distributed energy resources, or DRs.
DRs, got it.
These are just the smaller scale power producers. Think rooftop solar panels, small wind turbines, maybe combined heat and power systems, CHP, that generate electricity and useful heat at the same time.
Like in a factory or a hospital.
Precisely. And a really key concept within this decentralized world is the microgrid.
Microgrid.
Think of it like a localized energy network. It can be connected to the main grid, but crucially, it can also operate independently if the main grid goes down. We call that island mode.
Like its own little energy island.
Exactly. It's like having your own energy lifeboat.
All right.
It bundles together various DRs and ensures power keeps flowing, especially for critical places like hospitals, military bases, data centers during those big outages.
That makes a lot of sense for critical infrastructure.
Definitely. And of course, none of this really works efficiently without energy storage. That's absolutely critical.
Batteries, basically.
Batteries are huge, yes. Lithium-ion, newer types like flow batteries, solid state, but also older established tech like pumped hydro storage. That still accounts for like 96% of utility scale storage capacity in the US historically.
Pumped hydro. Like pumping water uphill.
Yeah, pump water up when you have excess power, let it flow back down through turbines to generate power when you need it. Simple, but effective. Storage acts like the grid's shock absorbers.
Smoothing things out.
Exactly. It smooths out the ups and downs of renewables. You know, sun doesn't always shine, wind doesn't always blow, and make sure power is there when you need it.
So, local production, smarter management with microgrids, storage to keep it stable, and the ability to operate independently. That sounds, well, incredibly compelling. What are the big upsides? Why should people listening care about this shift?
Oh, the advantages are really significant, and they impact everyone. First off, maybe the biggest one is enhanced resilience.
Fewer blackouts.
Exactly. Local generation dramatically cuts the risk of those widespread cascading blackouts. If one local source has an issue, others nearby can often pick up the slack. It stops that domino effect.
Makes sense.
And to put numbers on it, think about this. The average U.S. electricity customer faces almost 8 hours of outage per year.
Feels longer sometimes.
Right. Whereas in Germany, which has invested massively in decentralized renewables, the average annual outage is only about 13 minutes.
13 minutes versus 8 hours. That's a huge difference.
Huge. Then there's increased efficiency and cost savings. Generating power closer to home means less energy lost in transmission over long distances. Those losses can be up to 8 or 10% in traditional grids.
So less wasted energy.
Less wasted energy, and it can also mean delaying or avoiding super expensive upgrades to the big central grid infrastructure.
Okay, resilience, efficiency, cost. What about the environment?
Big impact there, too. Decentralized systems make it much easier and faster to integrate renewable energy sources like solar and wind. That directly cuts our carbon footprint and helps us move towards those big climate goals like net zero by 2050.
Accelerating the green transition.
Absolutely. And there's an equity aspect, too.
Yeah.
Energy, equity, and local autonomy.
How so?
Well, these systems can bring reliable, clean power to communities that are maybe too remote or too costly to connect to the main grid. Think rural areas, underserved urban neighborhoods.
Giving them power security.
Yes, and empowering them to have more control over their energy future. It can also spark local economic development.
And jobs.
And jobs, definitely. Decentralized systems, especially things like solar installations, tend to create more local jobs per megawatt installed compared to massive centralized plants. So it boosts local employment.
Resilient, efficiency, cost savings, environmental benefits, equity, jobs. That's a pretty compelling list of advantages.
It really is.
But, okay, as we always find with these massive transformations, it's rarely smooth sailing, right?
Yeah.
It sounds great on paper, But what are the real roadblocks? What's actually standing in the way of this becoming the norm everywhere?
You're absolutely right. The transition definitely has its hurdles, and probably one of the biggest is the regulatory framework.
The rules and regulations.
Exactly. Most existing energy regulations were designed, decades ago for that old centralized utility model. They often make it complex or even create disincentives for people or businesses wanting to generate their own power.
Like making it hard to connect solar panels.
Yeah, interconnection rules can be tricky, and policies like net metering, where you get credit for sending excess solar power back to the grid, they need constant tweaking to be fair to everyone as more solar comes online. It's a moving target.
Okay, regulations are one hurdle. What else?
Then there are definitely technological integration challenges. It's not simple to balance all these intermittent renewables, solar, wind, with other sources.
Keeping the lights on reliably.
Precisely, and making sure all the different pieces of equipment, often from different manufacturers, can actually talk to each other and work together seamlessly. That needs really sophisticated control systems.
Interoperability.
That's the word. And cybersecurity keeps coming up. Smart grids are great for efficiency, but all that interconnectedness does increase the potential attack surface.
More doors for hackers to try.
Kind of, yeah. And a lot of the devices being connected, smart meters, thermostats, even some legacy grid components might have vulnerabilities that could be exploited.
Right. So regulations, tech integration, cybersecurity. What about money?
Ah, yes, economic barriers. The upfront investment cost for installing decentralized systems, solar panels, batteries, microgrid controls can be pretty high.
Even if they save money long term.
Even then, that initial cost can be a major hurdle, especially for, say, developing countries or lower income communities.
Makes sense.
And you sometimes see resistance from traditional utility companies. Their whole business model for a century has been based on selling kilowatt hours generated centrally. Decentralized energy disrupts that.
Threatens their revenue stream.
Potentially, yeah. So navigating that transition requires new business models for utilities, too.
Okay, and you mentioned something earlier, the duck curve. What's that about?
Ah, the duck curve. Yeah, it's this fascinating but challenging phenomenon you see in places with a lot of solar power, like California or Australia.
Okay.
So during the middle of the day, when the sun is shining brightest, all that solar power floods the grid. This pushes the net demand the grid actually has to meet from traditional power plants way down. It creates this dip like the belly of a duck on a graph.
Okay, I can picture that.
But then, late afternoon, early evening, the sun starts to set, solar power drops off, and people come home from work, turn on lights, appliances, AC.
Demand shoots up.
Shoots up really steeply. That's the duck's neck. And managing that incredibly rapid ramp-up in demand is a huge challenge for grid operators. It requires power plants that can turn on very, very quickly.
So solar creates its own grid management headache.
It can, yeah, if not managed properly with things like storage. And there's one more, maybe slightly more philosophical challenge academics talk about.
Ah.
It's this idea of re-centralization by proxy.
Re-centralization.
Yeah.
But isn't the whole point decentralization?
Exactly. The concern is that while the physical generation of power becomes decentralized solar panels everywhere, the control over all these distributed resources could become centralized again, but this time in the hands of just a few big companies providing the software platforms that manage everything.
So sexting control from utility monopolies to tech monopolies.
Potentially. It raises questions about true energy democracy and who really benefits. And finally, we also need more research on the long-term environmental impacts.
Yeah.
Like, what are the full life cycle impacts of making millions of batteries? Where do the materials come from? How do we recycle them effectively? We need to think about resource depletion and the circular economy for all these new components.
Wow. Okay, so regulations, tech integration, cybersecurity, cost, utility business models, the duck curve, potential re-centralization, and life cycle impacts. That's quite a list of challenges.
It is. It shows this isn't a simple switch to flip.
Definitely not.
Yeah.
But it sounds like there are a lot of smart people working on these problems. So let's pivot to the solutions. What's being done? What are the innovative approaches and strategic solutions that are actually helping us overcome these hurdles?
Yeah, the good news is there's a huge amount of innovation happening across the board. The outlook is genuinely hopeful.
Okay, give us some examples.
Well, first off, on the technology side, you have all these smart grid technologies becoming more mature, things like advanced metering infrastructure or AMI. Smart meters, yeah. They give real-time data on energy use. Then you have energy management systems, EMS, to orchestrate everything within, say, a building or a microgrid, and distributed energy resource management systems, DERMS, which utilities use to coordinate and control all those DERAs out on the grid.
So basically the digital brain power to manage this more complex system.
Exactly. It's the nervous system allowing everything to work together intelligently. And building on that, we're seeing the rapid rise of virtual power plants, or VPPs.
VPPs, we touched on that. Tell me more.
So a VPP isn't a physical power plant. It's a cloud-based system that aggregates lots of distributed resources. Could be home batteries, smart thermostats that adjust AC use slightly, EV chargers that can pause or slow down charging.
All linked together digitally.
Right. And it controls them as a single unit, making them act like one big flexible power plant that can provide capacity or grid services back to the utility when needed.
So my home battery could be part of a VPP.
Absolutely. It effectively turns energy consumers into active grid participants or prosumers.
Interesting. What about getting power across longer distances?
Yeah.
We still need that sometimes, right?
Oh, for sure. Decentralized doesn't mean no transmission.
Yeah.
And there are advancements there, too. High voltage direct current, or HVDC lines, are becoming more common.
HVDC.
Yeah, they're much more efficient than traditional AC lines for moving large amounts of power over very long distances, hundreds or even thousands of miles, with significantly lower energy losses. China's built a massive HVDC network, for example.
Complementing the local generation.
Precisely. And looking further out, there's even research into superconducting cables, though that's more futuristic.
Okay, tech is moving fast. What about the money side? Addressing those cost barriers, is maybe the control issues?
Great question. Digital financial instruments are playing a really transformative role here. Blockchain technology is one key area.
Blockchain, like Bitcoin.
The underlying technology, yes, but applied to energy. It enables things like secure, transparent, peer-to-peer energy trading.
So I could sell my excess solar power directly to my neighbor.
Exactly, without necessarily needing the utility as the middleman for the transaction. The Brooklyn microgrid is a famous example of this. Blockchain can also be used to create tokenized energy assets, basically allowing fractional ownership of renewable projects.
Making it easier for smaller investors to get involved.
Yes. And that ties into decentralized finance, or DeFi. It uses blockchain to build new financial systems that are more open and accessible, potentially allowing a much wider range of people and communities to directly fund and benefit from clean energy projects. It fosters financial inclusion.
Democratizing energy investment.
That's the idea. And finally, policy and investment models are crucial and evolving. Public-private partnerships, or PPPs, are often essential.
Government and private companies working together.
Right. They help bridge financing gaps, share risks, and speed up the deployment of big projects, whether it's large-scale renewables that feed into the grid or community microgrids. And supportive government policies are huge givers.
Like tax credits or targets.
Yeah, exactly. Things like the U.S. Inflation Reduction Act or the EU Green Deal provide significant incentives and regulatory certainty that really encourage investment in decentralized energy and renewables. It's this mix, tech, finance, policy that's pushing things forward. Oh, and the circular economy idea, too.
Right, dealing with the life cycle impacts.
Yeah, really integrating recycling and reuse into the design from the start. Thinking about how to recover rare earth metals from wind turbines, how to repurpose EV batteries. That's becoming increasingly important.
It really is a multifaceted approach, then. Technology, finance, policy, even rethinking materials.
It has to be.
Okay, it's fantastic to hear about these innovations. Let's make it even more real. Can you give us some specific, real-world snapshots? Where is this stuff actually happening right now?
Absolutely. There are great examples popping up all over. A really cool one is the Tesla virtual power plant in South Australia.
Okay, so
Yeah, they partnered with the government and homeowners. Thousands of homes got solar panels and Tesla Powerwall batteries. These are all networked together to form a VPP.
acting like one big battery.
Essentially, yes. It helps stabilize the grid, especially during peak demand times in the summer, and reduces the need for expensive backup power plants. It's a powerful demonstration of community-scale energy working.
That's impressive. Where else?
Well, Germany's their energy transition is probably the most ambitious national example.
Right, you mentioned their low outage time.
Exactly. They've made massive investments in decentralized renewables over decades. As of 2025, something like Over 46.9% of their electricity comes from decentralized sources. That includes huge numbers of rooftop solar installations and community-owned wind farms. It shows it can be done at scale.
A whole country shifting its energy mix.
Pretty much. And back in the US, I mentioned the Brooklyn microgrid earlier. That's a really interesting case study using blockchain for peer-to-peer trading
Neighbors selling power to neighbors.
right within their community. It allows residents and local businesses with solar panels to sell their excess energy directly to their neighbors, creating a hyper-local energy market.
Very cool. Any others, maybe outside Europe or the US?
Sure. Masdar City in the UAE is fascinating. It's a planned city designed from the ground up with sustainability in mind.
Built for this purpose.
Yeah, heavily focused on decentralized renewable energy, super energy efficient buildings, smart grid tech, even waste-to-energy systems. It's like a living laboratory for sustainable urban design.
A glimpse of the future city, maybe.
Perhaps. And in the Netherlands, they're doing interesting work integrating electric vehicle batteries into the smart grid, the whole vehicle-to-grid or V2G concept.
Using car batteries to help the grid.
Exactly. When EVs are parked and plugged in, their batteries could potentially provide storage or send power back to the grid during peak times, helping with stability and making better use of those battery assets. It also ties into that circular economy idea.
So many different ways this is taking shape around the world.
It really is diverse. Different regions focus on different aspects based on their needs and resources.
This deep dive has been, wow, truly an exciting journey, hasn't it? Feels like we've covered a lot of ground. We certainly have.
And it's just so clear that the future of energy isn't only about those huge, distant tower plants anymore. It's becoming this much more dynamic, intelligent network where, you, the listener, the individual energy user, actually get to play a much bigger role.
Exactly right. And I think it's important to emphasize we're not really talking about completely abandoning the centralized grid overnight.
No, it's more of a blend.
It's a shift towards a hybrid future, a future where centralized and decentralized systems work together, complementing each other. That synergy is really key for maximizing resilience, boosting sustainability, and creating what some people call an energy internet that truly serves everyone fairly.
An energy internet. I like that.
But it requires continuous innovation, adaptation. We have to keep learning and adjusting as we go. Absolutely. So as you, our listener, reflect on everything we've unpacked today, maybe here's a final thought to mull over. How might your own daily energy choices and these rapid advancements in decentralized systems we've discussed, how might they reshape not just our power grids, but the actual fabric of our communities in the coming years and decades?
It's a powerful question to consider. The impacts could be quite profound.
Definitely something to think about. Well, thank you so much for joining us on this deep dive today. It's been fascinating.
My pleasure. Always great to discuss this stuff.
We really hope you enjoyed it, and we can't wait to explore more intriguing topics with you in our future deep dives.